All right, we're back. We are COMP305. That's Game Programming 1 in the fall 2017 semester at Centennial, and we are week 2, part 3 of our broadcast. We're still doing an intro to Unity. We're just continuing that. So where last we left off, we put everything up on GitHub. There's MailPilot on GitHub, this little thing, and we talked about creating a WebGL build and the positives and negatives around that, right? On the positive point, making WebGL build is good. On the negative, it does take a bunch of extra space. And so this builds folder in WebGL build, about 40 megs, something like that. Okay. Now we've got nothing in there. We've got a few assets and really nothing else in there at all. Once we start adding new assets, like for your game can spiral. And I know that some games have been upwards of 200 megs, the build part, before you start deploying, right? That's huge. And it'll take you a long time, and sometimes it'll actually crash out if you try to upload it to GitHub. GitHub can take a bunch of space. It doesn't give you limitations, but it just might take a lot longer than you think. Not do that later on. Okay, so cool. I also talked about how to use GitHub Pages really briefly. GitHub Pages to store your website eventually. And it gives you directions here on how to do that, right? From like step 1 to whatever. So you can do that on your own time. I won't be doing that with you right now. Also, I recommend, if you can afford it, you and your team buy the domain for your game. So I usually use GoDaddy. It's nice and simple. There's other providers, registrars as well. If I go to GoDaddy, I don't know, Winston, what's your game? What's the name of your game? The Weevils or something? Huh? The who? Oh, yeah, it's a weird name. What does it say? Spell it for me. Vincent, maybe you can spell it for me. How do you spell it? Yeah. Y-Z-Z. Y-V-A, that's it? So if I look for that, chances are it'll be available for that kind of crazy name, right? But if you put it in, you can see that when you look for it, it says, yeah, it's available for 16 bucks. Don't buy that one. Take a look at these ones, right? The ZYZZYVA.ca is worth $4.99 a year, right? That's pretty good, right? And there's other ones here you can look at as well, like and I recommend, I'm talking about from the business side of things now, right? There's two that you want, either the .ca or the .com. If the .com is taken, by the way, it might be taken. It is. I can't believe it, right? It's taken, right? So that's okay. But if it was taken, you can still use the .ca. It's not going to kill you for this if you use the .ca website. So you can buy this one. There's also other ones. Sometimes .xyz is available and some other ones like that. It doesn't matter. The cheaper, the better. All you want to do, like, look, this one's ziziva.me. All right, there's other ones here as well. You want to pick the lowest one because you don't want to pay extra money. And it's $4.99 for the first year. You can always not use it after that. You don't have to use it for the whole year. It'll try and auto-renew and all that stuff. But you can sign up for GoDaddy and buy that, right? How about one more name? Let's see another name. What's your game's going to be called? Oh, that's definitely going to be Tanker. So Tankers Royale, like this. Okay, let's try that out. So Tankers Royale. Okay, well, we got one. Okay, the .ca for $4.99. Go buy. Oh, even the .com. Way better to have, in my opinion. If you can have any site for your app, buy the .com if you can. But look, it costs $14.99. And, we're poor students. We can't afford more than a few bucks, right? So I recommend just taking the $4.99 one. As long as you live in Canada, you're okay, right? You can do that. Look, this one's even cheaper. Oh, I like this one. Buy this one, tankersroyale.xyz, right? For $1.49, right? That's for the whole year, $1.49, right? What's wrong with that? It's pretty cool. There's also tankersroyale.info. If you don't like that, Tankers Royale Life. That's a good one too. The Tankers Royale Life, right? $3.99, right? Why am I recommending this? Because once you buy it, you can point it with some help. You can point it at your Git Pages account, right? Your Git Pages, actual custom domain name that points to your GitHub account to make it run. And I think it's pretty cool, guys. Like pretty right on, right? So nothing wrong with doing that. You can also use Microsoft Azure if you want to have that as a base, or Heroku, one of the two. There's a bunch of other ones you can set up as well. But I would recommend if you're serious about making games and showing off your game, buy the domain for your game if you can, right? All right, that's a bit of an aside. Let's get back to well, we're moving away from the business of games for a second, and let's get back into scripting. So I'm going to launch Unity one more time. And I want to make my game, my game object move, right? So I've got my little object here for a second. One day when it comes up, it's loading. And yeah, I'll ignore that for now. I'll upgrade later. All right, cool. So take a look at this. This is what my game would look like when we tested it in WebGL, and it works. But in order for me to do anything with my game, I need a script, okay? And the way Unity works is scripts are attached to game objects. You cannot make a script that just hangs in the ether, right? You can make an empty game object, and the script can attach to that, right? But your script must be attached to a game object. So there's two ways to attach a new script, all right? The one way to do it is to click on the player object and click Add Component, because remember, the game object is made up of several components. Notice I have 3 here, right? I have the transform, which is part of every game component, right? I have the sprite renderer, which actually points to the sprite that I'm loading, right? I have a default material, sprite default. I have the draw mode, simple draw mode, and I have other things, which we'll talk about later. Then I have something else called, this is my default material, sprites default, right? Which actually is the material for my sprite. And that's it. I want to add a script component. So I'm going to click on Add Component. Notice there are a bunch of components you can add. And if you want to do it quickly, if I type in script, right, new script, that's one way of doing it. Okay, so I can type new script. Okay, cool. So that's one. So I can add component. Let's just get out of this. I can also scroll down and go new script, and then type the script that is whatever it's called, right? I can also specify the language, C# or JavaScript. We'll never use JavaScript here in this class, only C#. That's the second way to do it. I'm going to click away. The third way to do it, which I recommend more than the other two, is go into your scripts folder, right-click, and create a new script, a new C# script. Let's rename this thing player script, or player. We'll call it the player controller, right? So player controller. Okay, so I've gone into my scripts folder. I made a new player controller script. I get a preview what the script looks like on the right-hand side. If I double-click the script, what it will do is it'll pull it up in, it'll pull it up in MonoBehavior. MonoBehavior is the built-in Unity editor, right? However, if you're using Visual Studio as your default editor, it'll pull up there, right? Now, you can use whatever editor you want, but notice that MonoBehavior is pretty good. By default, all scripts start off with these two methods, the start method and the update method, okay? We're going to go into more detail about scripting later on, but the thing that you should know is the following. The start method we use for initialization, like it says here. The update method is called once per frame for non-physics events. There's actually 3 different update methods, right? There's update, fixed update, late update, right? I'm putting it out there. And for you to know the life cycle of your game, if you ever want to figure that out, you can always look at the Unity scripts. If I say Unity Lifecycle, if I type that in, right? Order of events, it's a really good thing to look at. And in fact, this execution order of events is how all the events trigger in Unity, right? And it gives you a little map of what it looks like. Here's something. It says, so my reset method, if I want to create a reset method, I'm going to make this a little bigger for you guys to see it remote, right? People who are watching this video as opposed to physically being in the class today. Actually didn't do anything, except for make my, but notice that the reset method is the first thing, and it updates the editor, the Unity editor, right? Awake is a method that's inside that can be used for initialization. On enable, when the the app is enabled, the start method, which we see. Then it goes to fixed update, right? Some kind of internal fixed update on trigger, some different collision checks, some different mouse checks. Then finally it gets to update, which is the game logic piece. So physics up here happens first. Then there's game logic. That's where your update happens, right? And then a bunch of other yields here. Then late update. Now, the reason why we have update and late update is sometimes what we want to do is we want to have multiple updates, one that happens first, and then once we do some cleaning up with coroutines and so on, something that happens after that. Then we have some scene rendering methods that trigger that you can call if you really want to. The gizmo, which is that manipulator arm that you see the red, green, and blue arrows, right? And other ones. I'm not going to go into too much of this, but you can see that from the life to death of your app, there are different methods that are triggered automatically. Okay, the ones we care about initially are start and update, but we can always call the other ones as well. Yeah, it's kind of a really high level overview. So these are the two methods that we start off with. Okay, cool. Well, what I want to do, in order for me to move my player with my mouse, I need to get input somehow. Okay, I need to get input somehow. Let's look at the back to the scripts in Unity. So I want to get input, right? So I want to get this. How you do it? Get input, mouse. Unity, right? If I put that in there, right? API input. Get mouse button down, and there's get mouse position. That's the one I want. And it shows me, this is really great about Unity, it shows me a little sample code about how to do that. Okay. Now you might look at this and go, whoa, 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 well, what the heck? What is all this stuff that we're doing here, right? Well, this is how you do it. Input is your input class that's built into Unity, right? Remember, we're using C#. So I'm going to call the input class. And notice this is happening inside of update. There's my update method, right? And then there's some other stuff here. And you're looking at it going, what the heck is all this? Right? Well, what I really want to say is whatever my mouse position is, right? My mouse position gives me X and Y coordinates, right? I should be able to move my plane around with my mouse, yeah? No. I'll show you why in a second. All right? So if I go back to my code, here's my code. Let's try this out. So I'm going to say, I'm going to start typing input. If I say get, notice that I can go get mouse, right? If I say mouse by itself, I can look at mouse position, right? And if I look at the example, it says input, right? Mouse position, right? It's got to be in the same thing, mouse position, lowercase. And if I want to print out this every frame, right? I can do a debug.log. .log. Let's try debug.log, right? So that every frame it's going to show my mouse position, right? That's what I want to do with my update for now. Okay, cool. So I've got my start method and my update method. My update method I've added in this debug.log so I can get my input.mouse position. Okay, cool. But however, we're never going to make this happen because my player controller is not attached to my player right now. So if I click on my player, notice there's no script controller on this. I'm going to drag and drop from my player script, my scripts folder, to my player object until I see this plus button come up, right? Or until I see that there's this little thing is going to be added in. See how I add this in and it actually goes in there? If I actually let go, it'll actually connect my script to my player object. I can also, if I don't like that, remove my script, right? Let's remove my component. Okay. I can remove components. The other way to do it is I can add component. I can go back down to new script, right? Or I want to pull in existing scripts, right? I want to add this script component in there. I want to add a new script component, right? But this actually creates a script. I want to choose a script that I want to have, right? All script that already exists. So if I type in scripts, oh, here's one here, up here, scripts. And then I can actually pull a list of scripts. This is the one, player controller. And that's another way to do it. So it's the second way. So one is drag and drop. The other one is do it this way. So now let's just leave it this way. So it's connected, right? And let's press play and see what happens. So I'm playing. Notice my mouse, my window changes color. And look, take a look at my cursor, my window now. So I've got it up here. Notice I get X, Y, and Z components. But I'm going to the top left corner of the screen. And the top left corner looks like it is, the X coordinate is 0. My Y coordinate is 477. That's weird. If I go over to the right, my Y coordinate is 442. What the heck? And if I go down here, my Y coordinate is 0, almost as I go down the bottom of the right-hand screen. If I go to the left, on the bottom left corner, I think I got a 0, 0. So it looks like it's drawing my coordinate system for my mouse from the bottom left corner, right? Which is totally whack compared to everything else. So how the heck do I translate what my mouse is doing compared to what my player is doing? Because my player's coordinates, if you notice, is not that. If I look at my player, this is while I'm playing, by the way, notice that my position is 0, minus 200, and 0. That is my screen. But meanwhile, if I look at my mouse is telling me that the 0, 0 point is way back here. Something not right. That's not right, right? That's why I can't directly, I can't follow my mouse out of the box like this. I gotta convert it. And the script online actually helps us to do that. If you look at the script online, let's go back to this. It says, I want to, my camera, my main camera, screen point, right, to ray, it says, my input dot position, my mouse position, right? And what this is creating is a ray, an actual ray that it's drawing. It's instantiating a new ray. I don't want to do this, but the idea is the same. Screen point to something else. So camera.main.screen point to whatever, and I want to take as an input my input.mouse position to give me some kind of new position for my screen, right? So whatever that position I'm going to get back, whatever the output of this is the actual coordinate system. So I'm converting from my viewport space to my camera space. That's what I'm trying to do. I'm converting those two spaces. Otherwise, my coordinate systems are all out of whack. All right? How do I do that? So let's use the same thing. So camera.main.screenPointArray. Let's see if there's other things we can put in there, right? So let's see if we go in there. Now, I want to define stuff. I can use the var keyword, right? Var in C# actually is, without knowing what kind of type it is, it will dynamically type, or actually implicitly type, not dynamically type, implicitly type the variable that I have. So I'm going to call this thing position. So var position is equal to, and I want to do that, camera, right, dot main. Let's see, just like it says here. So camera dot main, well, maybe camera with a capital C, camera dot main dot, okay, what other things can I do with my main camera? Well, doesn't really give me like a lot of options here. And it looks like they're all crossed out. Crossed out means the deprecated. All right? That's what it all means. So all these things are deprecated types, right? By the way, you may get better code hinting when you're using Visual Studio than I do in here, right? But I'm just going to show you all the different things that you have options to. So I want to do screen point to array. So let's see if I can get some code hinting. So I'm going to say screen point. And there's a bunch of different words. Screen point to array, screen to viewport point. Maybe that's better. Screen to world point. Viewport to screen point, and world to screen point. So I can convert from one coordinate system to the other. Which one do I want? Well, let's try screen to viewport point. This one. Let's see what I get first. So I do this one, right? That's what this position is now. And I want to pass in, remember? I want to pass in a vector3 position, right? Which is my input.mouse position. Position, there it is. That's what I'm passing in. So now, instead of doing this directly, I want to put in position. Okay? You're going to say, what the heck is Tom doing? Why am I converting coordinate systems? You need to. All right, so I save this. So Command S for save, or Control S. Go back into Unity, and let's stop running and rerun. If I get an error, it's going to come, okay, cool. Now let's take a look what I got. Okay, so here, I'm going over here. What the heck? Now I got 0, 1, 0, and in the middle I got 0, 0, 0 probably, right? Or maybe down here 0, 0, 0. Well, that's not what I want. Remember we talked about normalized viewport, where I kind of showed you the viewport size as 0 to 1, where 1 is 100% and 0 is 0%. That's what this one is doing when I convert from viewport size. So that's definitely not the coordinate system that I want back, right, with my mouse, right? Let's stop this. So that's this option. So that's screen to point. How about screen to world point? That sounds more like it, right? I'm not gonna torture you too much more. So screen to world point. Let's try that one out. All right, see what I get now. Save, and let's run it again. All right, and yeah, right. That looks more like it. Let's take a look. Yeah, it's about 200. Take a look. Here's 200, which minus 200, and this is about the middle of the screen. So that to me, right, looks about right. Would you agree? And that's what I'm saying. So when I move my mouse left and right, I want to move my plane left and right. I want my plane's position. Notice my transform position. I want my plane's position to be where my mouse is. So let's stop that. Okay, let's go back to mono behavior. And that's what I want. So this is my position, and this is my mouse position. So notice my input.mouse position. I've just called it, I can call this my mouse position, right? Like this. Notice that one won't clash with the other because input.mouse position is a property of the input class, and mouse position is a local variable that I've created in my update method, right? So every round, every frame, my mouse position will be created and destroyed. I won't care about what happened last time, right? In this particular case. And now I don't care about my debug log. I already figured that out. What I want is a reference to the position of my player object, right? Well, the great thing is that I have access to the transform of my player object. So all the components that are built into my player object, I have access to these things because my player script object somehow, right? So let's see if I can do that. Let's see if I can just say transform dot position, right, is equal to mouse position. See if I can do that now. So every frame, I'll put some comments in there. Every frame, set the player's position to the mouse position. All right, that's what I want to try and do here. Save. All right, if this works. Notice that I didn't say X and Y. I didn't say X, Y, and Z because you can never do that. You have to create either a new vector3 object, or you have to assign a vector3 object that already exists, which is this one right here. And if I hover over, notice like var, it tells me that by default, my mouse position itself is a vector3 object. I didn't know what it was going to be, let's say, but I can always change this to a vector3 if I really want to. Here's my new vector3 object, and that is the camera.main.screen to world point object that I'm passing in my input.mouse position to, right? It's converting it, my input.mouse position to screen to world space, right? It's storing the values, the X, Y, and Z properties inside my mouse position object. And then I'm taking my mouse position object and assigning the X, Y, and Z coordinates to the transform.position of the object that this script is attached to. Okay? Now, if everything works out, and if I press play, then I should be able to move my mouse around. Oh, man. What the heck? Where's my mouse? Right? Where's my ship? Look, here it is. It's way over here, and it's still moving. And when I move it, it's like totally not the right place. It's minus 244. And what's happening? Well, let's take a look at my scene. My mouse is way up here. My position is way out here. Why? What's happening? We're almost there. So here's my game screen, and here's my scene, right? And if I move my mouse down here, and if I switch tasks for a second, right? Switch tasks for a second. I move this out and back to Unity, and I move down. Look, keeps track of my mouse position, right? On the screen. That's not right either, right? That's why my player is up there, because my player is keeping track of my screen to world space, right? What should I have done? Do I really want my mouse or my player to move this way and that way? Yes, I do. But I want the X coordinate of my mouse to be the one that's affected, right? I don't care to move my plane in the vertical direction in any way. So I don't care how much vertical I do. If I move my mouse up and down, I want just my player in the shooter game just to be stuck in this rut in the bottom of my screen, in where my X coordinate is -200. Right? If I should bring it back down, let's just do that. If I put my minus, while I'm playing, I can do this. If I say space for my player, I can do that. Or I can try and move them down like this, right? Let's take a look, right? So I can try and move them, but the problem is this is the last position that my mouse was in real gameplay, right? So it's trying to do what I'm telling him to do, but it's kind of out of whack, right? Let's go back to my script. So it's doing what I told it to do. It's taking my transform position, whatever my player's position is, and this is the, if I hover over it, the transform attached to this game object, right? And it's assigning the mouse position, whatever it is, to this thing, to my game object, right? But my camera to screen to world point, right? It's not exactly doing what I want it to do. In fact, my mouse position is on the X coordinate, right? That's what I'm doing, right? So what can I do differently? Well, I can break this up a little bit and to something like this is a new vector3 object. Hear me out here, right? Vector3 object. All I care about in the vector3 object is the X coordinate, right? And I can take this screen to world point stuff right here out and put it into this place right here, right? Dot. And I only care about my X component. That's the X component of my vector3 object, right? And then the other vector3 objects, I'm going to keep at -200 for my Y, F, and 0, F for my Z, because I don't care about my Z at all, right? Let's put this back over here. Can I do this? And what the hell am I doing now? Well, if you remember C#, I need to use the new keyword to create a new vector3 object. Vector3 object is a vector that goes from the origin to wherever I'm putting it, right? So my camera screen to world space, I just put it on a wall in one line. All I want is the X component of my vector. I've got X, Y, and Z. So I'm taking my X component and putting it in there, right? And then, if you notice what I'm doing, I'm setting my Y value to -200 every single frame. So it's not going to move from that position. It's always going to be at the bottom of my screen, right? And my Z value at 0, not -10, like it was trying to do. Okay? Why couldn't I see my mouse? Because it was at -10. It was matching what my screen, my camera was at. My camera's at -10. Remember I told you if my camera and my plane is at the same elevation, the camera can't see my plane because my camera is my plane is inside my camera, right? So this will probably fix the problem. Let's see if I can do it this way. And now my mouse position is still a vector3, but all I care about moving is the X coordinate, right and left, horizontal, not my Y. My Y will stay fixed. All right, let's see if that's true. So I run it, if it didn't make a mistake. And now you can see my plane moves from on the bottom left of the screen, and my cursor is in the dead center of my plane, which is what I wanted. Remember, absolute positioning. That's what it's doing right here. Screen to world space. Okay, now I'm getting a bit of a lag, but only because I'm broadcasting to you guys, and I'm trying to do something at the same time. But this is how fast my mouse is moving right now. This is what you guys should see. Let's go back to the code for a second and see that. So what did I do? How could I break this down to make it even easier for you guys? Because I kind of did it all in one line. All right, well, I can make another object, right? My object could be a float. Here's the other way to do it. Floating point object, right? And I could make this floating point object. I could call it the mouse X. So here's my mouse X, right? And that's going to equal this stuff. Here's the easier way to see it. Let's make it, we can have as many of these variables as we want, right? And then I can take my mouse X and put it in here, because really my vector 3 is X, Y, and Z, right? Is that not the same? Because let's take a look. I'm going to get this component here. If I hover over it, that's the great thing about mono behavior, right? And Visual Studio. It tells me that the X property of my vector 3 object, X, Y, and Z, they're all floating point numbers, right? So if that's the output, I need a floating point number on the other end. Or if I don't know what it is, I could just use the var keyword, and that would be fine too, right? I know it's a float. So now this vector 3 object, if I want to know what it takes, the vector 3 object itself takes 3 objects, and they're 3 floating point numbers, X, Y, and Z, right? Notice that they're X, Y, and Z. So if I take the X coordinate, it's going to plug into the X argument of my X, Y, and Z requirement for my vector 3 object, right? Once I know that, I've satisfied my requirements. Now you can see that it's a little bit easier for you to read, right? But all I've done is I've just taken this whole thing instead of creating an extra variable and put it in here. But let's leave it like this so you guys can see what it is, okay? And just for completion, I'm going to put this up here so you can see the comments, right? And let's run it one more time to make sure I didn't break anything, right? So here it is, right? My mouse moves around. Okay, here's one thing. But what about this other problem? Okay, I want to make my plane move perfectly, right? But here's the problem with my plane. My plane actually goes outside of the screen, right? I don't want it to leave the confines of my little screen here. How do I stop it from moving outside of my screen? Any more recommendation? Nah, that's too hard. Forget colliders. If conditions can work, yeah. So I can basically test. I can say, well, okay, cool. This would move my plane around. Oh man, now I got a problem. I'm not following solid principles of coding. Solid principles mean that, and if you go back to it, I'll explain maybe solid principles another. If you took C# with me, then you know you've seen that already. My method should only do one thing, right? So my mouse, it's doing a couple things here. I'm getting the mouse position and assigning it to my transform, right? So I want to get the mouse position here, right? That's the first thing I want to do with my method. But I also want to check bounds, right? I want to check bounds. And I want to check the boundaries of my mouse position. And I want to make sure that it doesn't go outside of the bounds. And I want to reset the boundary every frame to just outside of the edge. I want to push it back. So if I try and push it this way, it's going to push it back over. If I go this way on the other side of the screen, it's going to push it this way, right? So how do I do that? Well, let's write it in first, and then we'll separate it. Okay, but I'm not doing it right for sure. I don't want to do it here, transform position, mouse position. I want to do it here before I actually draw it to the screen, my new position. I want to check to see if the new mouse position is outside the bounds of my screen. First of all, what are the bounds of my screen? Well, you check them here. So if I look at my plane, you can see that, I'm going to zoom in here so you can see the screen, okay? You can see that on the right side, and this is what I recommend you guys do too, right? My plane can go all the way to about here. Would you agree? I don't want my plane to go outside of this place, this area here, right? Because then it would be like cheating. I can avoid the obstacles that I'm going to go. I'm just going to go right in there so you can see where that wing is. Do you see that the wing is outside and so is the shadow? That's not right. My wing should be right here, right? So let's move it back a little bit. So I'm going to move the wing back just a touch. Try and be as accurate as I can be so you can see this thing. There is my wing, and with the outline. Okay. So if you look at it, it's about 291, right? So if you go 291, right? That's where it appears. How about, now this is the great thing about Unity. It's got symmetry, right? So if I go to the other side, the other side over here, right? And I click on my plane. And if I put a negative in front of this, right? So negative, right? If I know that's the case, I know that 291 exactly and 291 on the other side is exactly perfect. It's almost like I want to create this minimum and maximum threshold. And I know guys are running a little bit over. Give me 9 more minutes, and then I'll finish this demo up so you can see exactly how we do it. I want this minimum and maximum threshold that I want to be able to do, but I want the user to tool with that, to play around with that. I don't want to hard code that necessarily, those values, because that's like an ugly 291. What the hell is that, right? So imagine if you could put the values inside the interface, the inspector. So I'm going to create a couple of public variables, and I want to expose them here on the inspector. So you can put in those variables yourself. Okay, let's see how that works. So in the inspector, we have the ability in Unity to control what's on the inspector. This is my base class, right? And I can create some public variables, right? And I want to create a public variable called min. So, and what I want to find is the left boundary or leftmost boundary. Let's call it left boundary, right? And this variable has to have some kind of type. So it's going to be float. It's a type of float. And I can set it to a specific value by default, right? Or not, right? And my public, I also want to make my public float right boundary. By the way, there's many ways to do this thing. We'll explore another way next week, right? And let's make some kind of comments here. So these are my public properties. This is bad, right? What are the ways to make a public property? I could make it so that they're getters, setters for now, right? But for now, let's leave it as is, and I'll show you what the difference is. Methods, this is my start method. These are my public methods. These are all public, by the way, by default. So these are public, right? Public. These are just what they are. They're not private, right? And if you look at, I can put another thing that says public methods for my code, right? So I can kind of separate my code so you can see that these are public methods. These are public properties, but these aren't really public properties yet until I have a getter and setter. Right now, they're like private public instance variables, right? Okay, cool. I'm going to save this and go back to Unity and just click away from the player and click back. And hey, guess what? Look, left boundary and right boundary, right? Why would I do this? Because it's much easier for us as creators to change it here and play with the values than change it in my code. My code shouldn't care, right? It should take any left boundary, right boundary, and I should be able to adjust it, especially if I want to reuse the same code for something else, like a player number 2, right? So let's just go into putting in. I'll put negative 291, right? I'll put that in there, and I'll put 290. So negative 290 and 291. Let's make it the same number. How about that, Tom? 290. And now I can test. Now that I've got these values in here, I can say something like the following. I can say if mouse position dot x is greater than the right boundary, then mouse position dot x is equal to the right boundary, right? There's a problem, but we'll talk about this in a second. Let's try this out. So if mouse position dot x, this is the new calculated mouse position, right, is greater than this dot right boundary, right? I'm just using this way of doing things. Mouse position dot x is equal to this dot right boundary, right? But it's not really true, right? And let's do the same thing for the left boundary, right? So let's try that out. So we know this is the case. I'm just going to copy paste, right? I'm going to put this, I'm going to change this to left boundary. Okay, so now I'm limiting my mouse position so I can only go right and left, but only within a certain frame. Okay, let's check this out and see if it works. So right, test it, and oh, what the heck happened? That's not right. Come on, tell me what I did wrong.
The left boundary, you had it greater than.
I messed it up. This should be less than, yeah? I'm glad you caught it. Let's try it again. Got the problem still? Let me see something. Wait a minute. How was I able to go? Oh, okay, this is good. Look at that. That's pretty cool. How about over here? Oh, that's pretty cool too, right? Would you agree? Left mouse, left boundary, right boundary. I can't go outside those limits, right? So, and now it doesn't matter where my mouse is, up here or down here. When I play the game, I can kind of play it like this. I don't have to worry about my mouse being over my player. By the way, I can also hide the mouse. Right now I'm showing the mouse, but I can hide it in Unity. right? So I don't have to show the mouse when I'm in gameplay. Might be a problem though for playing a web game, but I could hide the mouse. I could do all kinds of stuff. But do you see that we've got our player movement down? Okay. One last thing before we go for the day. Let's rebuild our WebGL, right? And make sure if it works, because it works here in the simulator, right? We don't know if it's going to work on our platform of choice, right? We must test it on a platform of choice in order for us to put it up on GitHub to make sure that it's a good commit, right? So we're going to go into that. We're going to go File, Build and Run, right? And now that I've chosen my build settings, right, I don't have to rebuild everything from scratch like the way I did. I don't have to create that new web folder. I don't have to get the the subfolder, my builds. I don't have to do any of that stuff. Exactly the same location it had before. Now, I have to warn you that sometimes what we want to do is wipe out that build, the stuff that's inside the build folder, and do it again because it could corrupt what we get out. I'm just telling you from experience, right? Could corrupt the stuff that we get out. And it's going to take a few minutes to do that. So let's recap. Well, this is doing that. Let's recap what we've done today, right? So it's going to take some time to talk about that. One, we've talked about pitching and how to set up your GDD. That's due next week. I will put up an assignment by the end of the day. You will see it that says your pitch and your, your actual GDD, the first draft of your GDD is due next week. And it's only going to be available for teams to submit to. I won't put that up, right? It'll be due next week by midnight. So next Saturday night by midnight, your GDD and your final, your pitch will be due next week, okay? Saturday night by midnight. We've done that. We've also talked a little bit about cameras, orthographic cameras and perspective cameras. We've changed our sprites to pixel perfect sprites, 1 by 1, as opposed to 100 to 1 ratio. We've done that, right? We've pulled in sprites inside of our document, right? Let's see if it works. We've done all that work, right? Look how smooth that is. Much smoother now on the web, right? And I can't go out of my, I can't go to my window. I can leave my window, but I can't leave my window here. And it goes really, really fast. That's really, really cool, right? That's great. And that's the first part of the game that I wanted to get to, just to get my mouse movement going so I can move my player, right? That's great. That's mission accomplished, guys. Let me just get rid of this and get rid of this. So I've done that. And now what I want to do before I finish up, I wrap up, is I want to close Unity. So I want to close down MonoDevelop, right? So I want to close down MonoDevelop. I want to close down Unity. First, I want to save my scene. Very important, right? Save my project, right? And I want to close Unity. So I want to say Unity quit. And once it quits, then I have the ability to go up there, right, and do something like this. Git add dot. It's going to take a few minutes or a minute or so to add this. Looks like a lot of extra stuff. Remember that my last build, right? My last build was 65 megabytes or something like that, or 64 megabytes, right? Let's see how big this build is. And I only added a player, that's it. And my player movement script, that's it, right? Let's see if you're right. And then git push origin master, right? What the heck? Oh yeah, I didn't add a commit. Git commit. I'm getting ahead of myself. I'll say git commit, and I want to add in what I did, which is added player movement. Now I'll do that thing again. Clear, and I'll just push it. Sorry for this little thing, this little window. Gives me my, well, I don't care about that. That's my little snitch protecting me. Arg, I hate that thing. And then git push origin master. I know some of you have to go. I apologize. Now let's see how big this is really quickly as it pushes up to GitHub, right? By the way, you'll have access to downloading it. If yours didn't work, hey, what happened? It actually reduced the script down to 57 megs, right? Well, it optimized a little bit, right? So we did that. We talked about GitHub at length and how to create your GitHub account, how to push it up to GitHub, how to build everything up and create a WebGL build, all those things today. And this is the first part of our Unity series on 2D that we'll be talking about through this entire course. I know it might be a little bit more detailed than you're used to, but this is where we're going with this kind of stuff. So you can see all the details. We're going to hit all the details. We're not going to skim any of the points as much as I can. And I'm going to try and help you script it out so that it gets you where you need to be for your final game. Any questions before you go for the day? Guys, thank you so much. And we'll see you next Saturday. I'm looking forward to seeing your pitches, which is going to happen first thing next Saturday when you come in. All right? Thanks so much, guys. Take care.